Good morning. This will be your CrtB&C marking scheme. Okay, so we have a force that we know that a force may cause an object to turn about a pivot, and we know that this turning effect is called the moment of the force. And so an MYP student decided to do an experiment to test how does changing the distance away from a pivot affects the turning effect of a force applied to it by making the stand of the clamp slightly tilt over. We have the material listed in this investigation. So as I said previously, strand IV is given to you already, the material and the method. We need to have the student to conduct his investigation and to write a good research question, hypothesis, variables, and then we will interpret all the result and data collected. First thing, in order to write the research question, remember that we need to first identify the independent and the dependent variable. As I said, in anything given to you, usually we will have a hint of what is the dependent and what's the independent. So if you check the word changing, you would know that what comes afterward means that that's one of the variable, and then we want to know how it's affecting, so that's also will identify what the other variable is. Okay, so it's really easy. The independent variable is going to be the distance away from the pivot. Now how can I get a level 5 and above? It's if you want to get a level 5 and above, then you need to add the scientific explanation and to be more specific. If you just say that it is the distance in meter away from the pivot to the base, you were on a level 1 to 3 max. Now by continuing and saying that, I'm gonna change. Okay, if I said this variable is continuous and it varies from 0 to 0.50, so I'm giving a range, then you're on a level 5 max. How can you jump to level 6 and above? You need to be specific and you need to give some explanation. So this is my explanation. During the investigation, the rubber band position is changed by placing it at 0.10 meter away from the pivot, which is the base of the stand, measured using a ruler meter. So I not only gave the tool, but I was specific by saying how much distance we're gonna increase. So if this is my clamp stand, okay, I'm going to increase it every time by 0.10 meter. I'm explaining to the reader. And this distance is increased by 0.10 between each rubber band until reaching a distance of 0.50. So I used my range in order to show, and by being scientific and specific, because I'm using the words that are scientific related to this topic, then I am now on a level 7 to 8. Okay, now what about the dependent variable? Since in the given we have affects the turning effect of the force, so this must be my other variable, which is the dependent, the thing that we're measuring. Again, if you want to be on a level max, a level of 1 to 3, then you just say it's the force in Newton applied on each rubber band. You're stating. If you want to reach your level 5, then you need to show that it's continuous and how we're changing it. Doesn't have a range. It does actually. Okay, so you need you need to mention here the range. So you should say since we're using the Newton meter, that is on a scale 0 to 10 Newton, so that's my range. Okay, I should add this to the marking scheme. Now, in order to have higher marks, we need to explain. So this is where the explanation part comes. That's the explanation. So every time you change the position of the rubber band away from the pivot, you hook the Newton meter to the rubber band and you pull onto it until the stand slightly tilts over. Then you record the reading in newtons. So I'm being specific, and then you record. I should be more specific here by saying you record the force, the reading, the force giving me the reading in Newton. Okay, so I'm just showing you how we actually like no matter what your answer might be, you would always find a way to make it even better. That's for sure. Now I can write the research question and my hypothesis. So for my research question, it's to which extent does changing the IV affect the TV. Now if I want to be again on a level, on a maximum level of 3, then you will say to what extent does changing the distance affects the amount of force. So only the things highlighted in green are the level 1 to 3. But I want to get more marks. So I'm going to be more specific and trying to use scientific words. So I'm gonna say changing the distance between the base of the clamp and the position of the rubber band, and then affects the amount of force. I'm stating again. I also will explain. Applied on the rubber band, required to slightly tilt the clamp stand about its position at rest. Okay? For the hypothesis, it's gonna be if the distance in meter between the point and the pivot of the rubber band increases, the force required to slightly tilt the stand will be less. So the things highlighted in green means that you're on a level 1 to 3 max. To reach a higher level, it depends on how much scientific and specific you are. So by saying slightly tilt the stand about its pivot, that's a scientific explanation. And then explaining furthermore by saying moment is equal to force multiplied by distance. So if the turning effect of the clamp stand due to the force is kept the same, then distance is inversely proportional to the force applied in Newton. So again, I'm using scientific words, I'm using scientific reasoning, and I'm being specific by stating the whatever formula you can use. So that's a formula, that's being scientific. Okay? And I'm sure you can always find a way to fix and to improve your answer. Next is gonna be the control variable. In the control variable, I'm just gonna show you the control variable and their explanation. I won't go through it. So same Newton meter scale used to measure the force, and then this is the explanation for the first one. I'm going to read them like that. So we use the same apparatus scale, which is 0 to 10 Newton. I'm being specific by saying which scale of Newton meter I'm using. It's a spring Newton meter. So I can add here same spring Newton meter scale. The same type of rubber band used. That's in order to have the same elasticity, and then the same motion objective. What do I mean by motion objective is how much I'm tilting my clamp stand. Okay, so let me show you. Let's say this is my clamp stand that I'm dealing with. The thing is that this is the force that I'm applying. It's towards the right. So what is happening is that I'm taking this clamp stand and I am pulling with this force. So what happens is that the clamp stand will start to tilt like that. Okay, so the force, the moment the clamp stand tilts slightly, I will stop applying the force and I will record the reading on the Newton meter. This is exactly my investigation. So what I say when I said the same motion objective, what I meant by that is I meant how much I am tilting the stand, because it won't be fair to tilt it on the first rubber band like till this degree, and then the second I tilt it even more. It won't be fair. So I need to keep the same moment as much as possible. Okay?